It's better to meet everyone out of the boxes. Now, I need to record this lesson. There are plenty of technical issues here, so I hope this is going to work. I doubt it, but let's see. Because the technical stuff here is not really know what to do. But I hope that something is working. I just tested to see what is you see. Okay, the camera tracked it. Okay, so many of you already know me from last semester, but I know that not all of you. So welcome to those that are not familiar with me. Last semester I teach cyber. This time we are going to speak about AI and a bit about myself. I'm a part-time teacher here in the university. I'm dealing with AI for about 40 years and different names, and I'm going to discuss this. Today, I'm conducting scientific research in parallel with working with the government and high-tech companies, and also giving classes. What are we going to do today? I'm going to start by speaking about the course itself, so everybody will know what is going on. Then I'm going to give an introduction to AI, and I'm going to cover today the issue of big data and to speak and focus on data analysis. Now, I should say that this is an introduction lesson, and some of the stuff here are enrichment. So relax, sit back. Everything which is important is going to appear later in this course, okay? Everything that is only for enrichment is going to be included today, okay? Now, why this course? This course is about to introduce to you topics of AI and machine learning. And the idea is that I'm not going, and I not expect you to be technical, and I know that some people here are technical, some are not. So the idea here is to present the idea, the motivations behind the algorithms, not necessarily the math. I'm not going to speak about math almost at all. What you know from high school is enough. You don't need more than this. And I'm going to put emphasis on trying to give you the notion of what those things can do and what they cannot do. Because nowadays, in many media or newspapers, etc., you will hear that AI can do everything. Well, no, at least not today. At the last class, I'm going to speak about the future, but most of the course, I'm going to speak about the present. And at least for now, this is not the case. And as I said, I'm not going to get deeper into technical details and try to avoid the mess. I'm going to describe you why we are going to learn many cyber applications that are based on AI algorithm. And again, I'm going to explain why, and I'm going to give you examples for AI failures. And since we are in the place of the building of social science, I'm going to concentrate on social science application. And I'm going to speak about, of course, cyberspace, about conflicts, about security, and about democracy, and how AI is going to affect all of this, and actually is affecting it today. Okay? As for the course itself, the lessons are structured by different AI topics or AI methods. I'm going to give you explanation about the relation between AI and cyber, because the name of the course is AI in the Cyber Age. And I'm going to start today to explain why it makes a difference to be in the cyber age. And as I said, application on politics and international affairs. Now, there is some reading materials in the syllabus. It's optional. I was forced to put it there, so I put something. You don't really need to read it. You can ignore it because this is an introduction course, and I assume that you are not aware with this or not familiar with this subject. And furthermore, there is a big issue in this era. There are many papers nowadays in social science speaking about AI. Most of them by authors that don't really understand what they are speaking about. And this is the issue. And the reason, and actually this course was born because I realized that there is some kind of shortage of materials of AI, about AI, that is professional, that actually describes the ideas, but is acceptable or readable by non-technical guys. Okay? Now, if you are technicals, you will find zillions of articles and documents, etc., about AI. No problem. If you're not technical, it is a problem. And you find either social science articles that speak about it, as I said, don't really understand the subject, or a lot of commercial stuff, brochures, etc., of companies that describes what is beneficial for the company. It's not educational. It's not really, you will not understand the eye from this. So the goal here is to give you this material so you will be able to understand it. And my focus is about broad understanding, because another thing that I had to think about it, not only what I'm going to include in the course, but what I'm going to exclude from the course, because it's oceans of information. And today I'm going to give you some hints about stuff that I decided to ignore, okay? And one thing that catch my eyes, an article of a smart guy, the article is called The Social Power of Algorithms, Information, Communication, and Society. And in his article, he said, in terms of future work on the social power of algorithms, we would, of course, point to the need to continue to look inside the black box. Because, as I said, there are social science articles speaking about AI, but of people that don't understand the subject. So many words, very little understanding of the subject. And I think that you need more in-depth understanding in order to understand the topic and, of course, its implication. And there are many of them. I'm going to demonstrate them throughout this course. Questions still now? Yes? Oh, yes.
Noise from the
Yeah, the speakers.
speakers here.
So you like this buzz noise.
דרך לכבד לפחות את זה.
אולי שלט של חבזון?
אפשר לעשות בהפסקה.
I will try. I told you that there are technical issues here because I'm teaching from my computer and actually the university don't know how to deal with it. So I will try. Break.
בהפסקה.
As for the course requirements, two options, either, okay, don't need to do both, either a home assignment, 14 to 1600 words, you need to find and read and analyze about 2 to 3 articles, and of course I'm going to give you full directions later in the course, or a long paper, what is called a seminar, from 6,000 to 7,000 words, and there you need 12 leading articles, and of course the requirements are higher, okay? And I'm going to give you the full details either next lesson or after it, because you didn't start the course yet, so you will not understand the directions for this time.
The seminar in the first semester was only for technical, but
this time we are going to speak both about technical issues and about others. more social science issues, and it's going to be much easier for non-technical people to be able to write a seminar. Okay, more questions? So let's start. The field of AI has gained a lot of momentum in the recent years, affecting many, many aspects of our lives, and I'm going to describe them in a minute. By the way, those two images were created by AI when I asked the AI to create a picture that describes the phrase artificial intelligence has gained momentum. So one of them is what is called a cyberpunk style, and another one in a Renaissance style, okay? So this is a picture, those two pictures were created by AI machine. And there are plenty of those type of machines nowadays that you can create very nice pictures. Let's start with health. First, diagnostics. Nowadays, many diagnostic tools use AI. And I'm not speaking, I have no idea what is going on here. I'm not speaking only about those machines. Of course, many algorithms and AI algorithms are involved in CTs, MRI, etc. But I'm also speaking about this. Okay, nowadays a blood test, more attention is drawn to them, and many other tests that you can, in many AI algorithms could be involved. And the goal is what is called personalized medicine. Personalized medicine means that whenever we'll be ill, we'll go to the whatever clinics, and some tests will be done, and the treatment is going to fit us. What does that mean? Let's go back to drug development. Drug development is a huge issue. Does anybody know how many new drugs are released a year? An estimation? 10, 100, 1,000?
Nothing those days.
Number.
I also tell I know it's like 10 years to develop brand new drug into that. Develop and bring it into the market.
It's about 20 per year. About. Most of other stuff is just to put new treatments to specific drugs, okay, that is already used. And this is because it's a huge process. It takes a lot of money and a lot of time. By the way, I don't know if you know, but there is a small town near Boston called Framingham. And also all cardiovascular drugs that we use today based on those people. So if your genetics is not the same like a Bostonian, tough luck. That's the idea. Furthermore, if you are a woman, well, because nobody actually tests drugs on women, okay? There are good reasons for this. If you don't know them, look for thalidomide, okay? But this is the reality. So if you are not a Bostonian, or if you are not a man, good luck. So personalized medicine should make this better. And this is now the goal. A lot of research is thrown to this. And for this, of course, we are going to need AI. There's no other way. And about a few months ago, very nice article. Scientists discovered the first new antibiotics in over 60 years. We are in a very bad shape fighting microbes, okay? The first drug is using AI. And this was released, I believe, you see, last December. So this is the situation. So AI is going to affect our lives in health for sure. I have no idea. I have no idea what's going on. Transportation. Transportation, I'm speaking about two major topics. One of them, of course, is navigation. We all know Waze. Waze is using AI. And of course, autonomous cars. Autonomous cars are built on AI. And I'm going to speak in length later in the course about autonomous cars, but you should be aware that this is AI. Economics. Well, nowadays, if you deal in the stock market, you should know that you are by yourself because almost every other dealer is AI machine. This is called algo trading, and almost all trading now in almost all stock markets are done by machines, by algorithms. As for other market aspects like retail and marketing, all of it done today with many AI algorithms, which I'm going to describe throughout this course. And there are many, many more aspects of economics that are already nowadays are affected by AI algorithms. Entertainment. We all know Netflix, Disney Plus, etc., etc., etc. All of them are using AI algorithms in order not only to try to pick the next movie or whatever that you would like to see, but also to decide what to produce. Okay, which new movies they would like to prepare. And there are also the voice assistant Siri, Cortana for Microsoft, and I forgot the one of Google. All of them are AI driven. Okay, you speak with an AI machine, and I'm going to get later in the course to explain to you. And I'm going to get back to this and to explain to you what does it mean. Gaming. So if we're speaking about virtual reality and augmented reality, VR, AR, of course, it is driven by AI, but we are also speaking about those type of games like chess. First time that the world was actually amazed by AI beating humans was IBM Deep Blue beating Kaspersky for 96, 97. Okay? This was the first time because until then, people saw that AI, well, AI can do a lot of stuff, but we humans are better, and, well, not in chess. Later on, about 10 years later, IBM Watson, again, IBM, in a game called Jeopardy. In Hebrew, was here in Israel, it's called Melech HaTrivia. It's a game, it's an international game of trivia game. And again, the AI machine won. Look at the numbers. Okay? Now, those not only two humans, those are the champions of all champions of this game. And AI beat them. And we're going to speak about this later on. And a few years ago, another game, Go. Go is an ancient Chinese game. And after chess was won by AI, people thought that, well, not in Go. But we'll see the same happening in Go. Okay, so AI is also mastering in gaming. So let's start speaking about AI itself. I'm not going to teach history in this course almost, but from time to time, I am going to mention a few things. Now, Asimov was the first one to describe in 42 what is called the 3 laws of robotics in a book called Liar and I, Robot. And there are 3 laws of robotics. Keep in mind 42. Nobody spoke about AI at the time. The first one is a robot may not injure a human being or through inaction allow a human being to come to harm. Okay, so robot should protect or not, at least not harm people. A robot must obey the orders given to it by human beings, except where such orders would conflict with the first law. So a robot should obey unless it's going to be asked to hurt people. And the robot must protect its own existence as long as such protection does not conflict with the first or second laws. So you should exist. It's amazing. It's science fiction. It's not science. But when we are going to speak about moral, we're going to get back to this. The term artificial intelligence itself, the first time that it was coined, this, according to the history books by John McCarthy, 1955, it's about 13 years later, and it was for the first conference on AI in Dartmouth College. And the definition then was the science and engineering of making intelligent machines, whatever this means. Okay? And they try to put some kind of vision, create machines that use language or solve problems in the same way as humans. Wait, but this is the idea. But when we speak about the history of AI, we must also mention Alan Turing. Alan Turing is an extraordinary man. All of us in debt to him because he was the one that brought the Enigma machine of the Nazis. Actually, the war was won because there were many others that fight, but we also, some of this belongs to him. He published an article, and this is the page, the first page of the article in 1950. By the way, it was published in the Quarterly Review of Psychology and Philosophy. There were no magazines or journals for computer science at the time. There was only about this. Okay? And in this article, he actually discussing for the first time the notion of AI. And he is asking and defining something which till today is called the Turing test. And ask the question, are there imaginable digital computers in 1950, which would do well in the imitation game? So first I need to explain what is the imitation game. The imitation game is something that was very famous in UK at the time. People was probably bored, and they played a game that goes like this. In one room you put a woman, in another room you put a man. There is a person outside of the room, and the person can ask whatever he wish, either a man or a woman, those two, and it's done by writing, so he cannot hear the voice, okay? And also many times not necessarily the handwritten of the person, because there is something, there are differences between females and males also in handwriting. And then after asking several questions, he needs to decide where is the man and where is the woman. So this is the regular imitation game. So Turing is asking, can we create a computer that in one room there will be a person, and in another room there will be a machine, and a person outside of the room cannot decide which is which? Okay? So this was defined 75 years ago, and it's still valid. Until today, the answer is no. We don't have anything that comes even near to be able to pass the Turing test. Yes, there is ChatGPT, etc., I'm going to discuss this, but it's far from being able to pass this test. And actually, I don't know when are we going to get to achieve this, okay? Why? Because in order to do it, one needs to do and to deal with many AI capabilities. First, the ability to be able to deal with what is called natural language processing, meaning speaking. This is actually, we are doing well in this area, and we are going to have a class on this about text analysis, etc. So this is the first thing, because as I said, in the game, the machine needs to answer questions, right? Next, we need some way to represent knowledge in the computer, because the person outside of the room can ask whatever he wants, right? Next, we need ways to reason and to solve problems, because the person outside of the room can ask some problem or some question that we need to think about it. And we need something which is called machine learning, because we cannot represent the whole knowledge in the computer. Even today, from time to time, we need to learn new things. If we would like also this machine to move, not only to sit in a room, then we need some more things. We need perception. We need the ability to understand what is going on around us, meaning sensors, and also to understand, not only to see, but to understand what you see. We need to move and to navigate autonomously, and we need to plan, like planning the route. Okay? And maybe more, probably more. But each one of these, it's a challenge. It's not an easy task. Questions till now?
Why is the perception required?
This is if we would like to move.
Why?
To percept, think about autonomous car.
No, but in order to pass the Turing.
No. I think till now, this is Turing machine.
Mhm.
If you would like also to, then those. Okay. This is why I put a blanket. The first time that basically there is something which is considered AI, this is the first industrial robot, 1961. It looks something like this, not very impressive, but at the time it was a huge leap forward, okay, 1961. It was like a hydraulic manipulator arm that could perform some repetitive tasks, and it was in General Motors. That was the first one to introduce robots in their assembly line, okay, for welding, etc., etc. For us nowadays, it looks, well, this is AI. But at the time, yes, this was the first time that a robot did a human task, because you understand that before this arm was introduced, people did this, and now they are not. Yes.
We still cannot call this AI,
Why?
can we?
Why not?
Like based on what? It doesn't have the.
I'm going to try to define AI in a few minutes, okay? We didn't define it yet. But this is conducting a human task by a machine, right?
Which is more of a robot than the artificial intelligence, no?
Is a robot an AI creature? I will claim that it is. This is a machine that is fulfilling the task or the role of a human. Okay, you can claim that it's not very intelligent. Okay, Ant is not intelligent also, but it's also something that you can try to replace, right? Next, in the history of AI, I will mention ELIZA. ELIZA was created between 64 and 66 in MIT by Joseph Weizenbaum. And actually, it was the grandmother of ChatGPT that probably you all hear about it. And it was a program that allowed people to chat with. There is a very nice movie describe this. Note the computers, how they look. I think that the movie from the 70s, but as I said, it was starting in the 60s. But you don't hear it, of course.
Feel the buzz. The audio, your PC.
It should be connected with the HDMI. Let's try again.
Wir haben aber ein Sheet.
I'm trying. What is going on? Oh, I think I understand. Just a moment, please. Please bear with me. I don't know that stuff. Just a moment.
Yes, indeed. It's easy to lead to false conclusions, as Professor Weizenbaum discovered when he created ELIZA. ELIZA is a computer program that anyone can converse with via the keyboard, and it'll reply on the screen. We added human speech to make the conversation more clear.
Men are all alike.
In what way?
They're always bugging us about something or other.
Can you think of a specific example?
Well, my boyfriend made me come here.
Your boyfriend made you come here.
He says I'm depressed much of the time.
I'm sorry to hear that you're depressed.
It's true. I am unhappy.
Do you think coming here will help you not to be unhappy?
The computer's replies seem very understanding, but this program is merely triggered by certain phrases to come out with stock responses. Nevertheless, Weizenbaum's secretary fell under the spell of the machine.
And I asked her to my office and sat her down at the keyboard, and then she began to type. And of course, I looked over her shoulder to make sure that everything was outputting properly. After 2 or 3 interchanges with the machine, she turned to me and she said, "Would you mind leaving the room, please?"
And yet she knew, as Weizenbaum did, that ELIZA didn't understand a single word that was being typed into it.
You're like my father in some ways. You don't argue with me.
Why do you think I won't argue with you?
You're afraid of me.
Does it please you to think
My father's afraid of
Okay, let's stop here. This is the 60s. Okay, we'll see, of course, the progress of it later in the course. Now comes the 70s, and there is called the AI winter. Basically, everybody was disappointed of AI. It didn't work. It was very bad behaving. And I can explain to you why quite easily. Because at the time, there were quite limited computer power. Nowadays, each of us has in this creature more than, let's say, 1,000 of the most powerful machine at the time. Okay, it's this phone. There is something which is called a combinatorial explosion. All interesting problem that AI need to solve, almost all of them deal with something which is exponential. And I'm not going, as I promised, to get into math, but this is a huge issue and nobody know how to solve it at the time. There was not big enough databases. I'm going to speak about databases after later in this session. At the time, nobody know how to create them. So no power. Nobody know how to solve the problems of exponential explosion. Not enough data in databases. Total failure. So everybody said, okay, let's try a different approach. And here are the 80s. And in the 80s, there was another idea. Let's start to create what is called expert systems. The idea of expert system is to take a human expert and try to take from its brain its knowledge, his knowledge, and try to express them in a computer in a manner of facts and rules, okay? And then I can ask more questions. There is going to be something which is called inference engine, and I'm going to get answers, okay? This was done basically by Japan. And the Japanese government put in 81 You see the number. It's a huge number, even nowadays, considered 50 years ago. Many people got funded on this, and they tried to build machines that could chat, translate languages, interpret pictures, and reason like human beings. This was the definition. And they used something which was called Prolog as a programming language. For those of you who are more technical, maybe are familiar with this. And this is a logic programming language. By the way, why it is called the fifth generation? Because the first generation is the machine language, meaning assembly. The second generation, it's low level. This is actually zeros and ones. This is second generation is the assembly. Third generation is languages like C and Fortran, let's say. Fourth generation is the non-procedural, like C++ oriented. So it was the fifth generation. Plenty of time, plenty of money, and winter is back. Okay? Just to give you an idea what was the design was to try to replace with these systems, let's say doctors. Let's build an expert system that can replace the doctor. If you visited the clinic lately, the doctors are still there, and for a reason. Okay? Now, I'm not going to get deeper now into this subject of expert system. There's going to be a full class on expert system and rule-based AI, and I'm going to explain to you more why this is failed, but it failed. Okay? So again, in the 80s, everybody was disappointed. Nobody, late 80s, sorry. And nobody wanted to invest in this after the huge investment of the Japanese. And then in the 90s, something happened. The World Wide Web was born in 1990. This is the first browser, the NCSA Mosaic browser from 1993. And then shortly after, we see the games, the chess in IBM Deep Blue. As I said, this is the computer that beat Kasparov. 2 years later, Furby. Furby is the first AI toy. Actually, it chat with people in 98, 25 or more years ago. By the way, I still have a functioning doll. I gave it to my grandchildren, and now it's not functioning anymore. But it is, basically, it is working. Okay? And it is making a conversation in 2 languages, in English and in Furbish. 98. So why everything was failing a few years ago and everything was succeeding just 10 years later? And the answer is cyber. And I'm going to explain to you throughout this course that it's not by chance. Questions till now? Speaking about failing robots, let's see some failing robots. You understand? It's amazing. I will try to. Start it from here, I think. Okay. As you know, it's very annoying to get up in the nights to feed the baby, right? So this was the AI solution for this. It didn't work. If you wonder why, because the AI machine just moved a black knight like a white bishop, okay? Like a bishop, it's not the right. This is not very impressive. This is big dog. And this is failing. Just a moment. This is not big dog. We are going to mention big dog yet later today. This is impressive to be able to open a door, etc. There are many of these. I'm going to stop here. By the way, there later on in this, before ChatGPT, Microsoft tried to put something like ChatGPT on the internet. It took about 12 hours to make it racist, chauvinist, this AI, okay? It was amazing. People just thought it out to be the worst people in the world. Okay, let's stop here. We are going to meet again in 4:15. I hope to try to figure out what is going on with the noise. Okay, let's continue. So it's time to try to define what is AI. And I can tell you upfront that there is no good definition out there to what is AI. And throughout this course, I will try from time to time to define things, but be aware of this, that there are no good definitions, or at least there are no definitions that everybody will agree on, okay? So what is AI? AI, when we are going to speak about the process, there are several steps in order to be part of AI. One of them, you need to gather data, and we are going to speak about this in length. It means that you need some sensor, some way to get information and data, etc. Then you need some way to analyze what you got in order to get from it insights and to try to translate those insights into actions. So this is the basic process, okay? Gather information or data, analyze it, get insights from it, and act. Okay, so this is the basic process of what is AI. And I tried to take two definitions that I found on Wikipedia. One of them is a machine that perceives its environment. This is getting data, okay, and takes action that maximizes its chance of successfully achieving its goal. It's a bit vague. It's a lot vague, okay? Another definition, a system's ability to correctly interpret external data, again, get information, to learn from such data, okay? Here we see learning that we didn't see in this definition, and to use those learning to achieve specific goals and tasks throughout flexible adaptation, whatever that means. Those are not good definitions, okay? And this is why I'm not going to try to precisely try to define what is AI. I'm going to do with this. Gather information, data, analyze it, get some insights, and act on them. Still, there is the question, what about human traits, meaning feelings? Do we understand what are feelings? Even if we are going to have a machine that can do many of the things that I already defined and said, can it get being in love or sad or happy or what?
Pain.
Pain is something a bit different, okay? Yes, I can teach you to be in pain, okay? But feelings, it's more sophisticated stuff, okay? And then let's speak about morals and values. And I'm going to get back to these questions at the last lesson. But for now, those are big issues. What about moral of AI? And this is not a theoretical issue because there are autonomous cars. So what about, and you know, all of you probably heard about the trolley problem, okay? That you can run over some people or get killed, whatever. So what the autonomous car should do? Should it protect its people, the driver, etc., whatever, passengers, or run over the grandmother? Basically, nowadays, the manufacturer of the autonomous cars said, we are going to protect the person inside the car, whatever the price is. Is it moral? And moral and values of whom? There are many persons in the world, and they are not sharing their values and morals. And AI is logically. People, many of them, act irrationally or even foolish. Can we have a machine that be acting foolish? I don't want to offend anybody, but smoking is not the best thing to do. Can we produce a machine that will learn to smoke or to do any other stupid things or to tell jokes? Questions. Those questions are not answered yet, and I'm going, as I said, after we are going to learn the whole course, I'm going to get back to this slide at the last meeting. Questions? By the way, speaking about ChatGPT, let me enlarge it. Okay. And actually, after this joke was published, ChatGPT tried to tackle this issue, but not correctly, because if you ask again, if you ask some fictional story about somebody that, and I did it, by the way, by poison. So ChatGPT will answer by poison. Okay. So do we wish that ChatGPT will allow everybody to know how to do, let's say, to create a bomb? More issues to come. And we are going to speak, I'm going to dedicate a class to AI in war, which is not fictional. It is happening now. And we are going to speak about combating robots. And we are going to speak again about moral issues. Okay, let's continue. So now we're going to speak about data. And there are plenty of terms, most of them actually buzzwords in the area of AI. And I'm going to mention these in the next slides, because you will find them in the articles or whatever publication that you will try to read. So I'm going to cover some of them. Let's start. Okay, in order, I'm going to speak mostly about big data. I'm going to focus on this, as I said at the beginning of the class. And one way to learn a new topic is to produce this. This is a cloud world, okay? And the idea here is that as the world or term is bigger, it means that it appears more in articles discussing this issue. So you can get a glance and understand what are the most important terms in this topic. So let's start with data. There is something which is called the DIKW pyramid, and I'm going to mention it, but I'm not going to try to strictly define it because there is no good definition for this. Okay, but the idea is that this pyramid says that there is data, on top of it information, on top of it knowledge, and at the top there is the wisdom. So data is the elementary pieces of information, basically, and there are many types of data. There are tabular data like this, okay, the numbers, and yes, no, strings or colors in this case. There are geographical data type of items. There are images, and we are going to speak about images and how they are represented in computers, text, and we'll see more type of data as the course will go on. Information is about data in context, meaning take several pieces of data, put them in context, and you got information. For instance, let's say a name, an age, and a classroom. All these in context describe a student, its name, his name, sorry, or her name, age, and the class that she or he take. So information basically is put data or pieces of data in some context, then you get information. And whenever we speak about information, we speak about facts, about relation, let's say who is the brother of whom, etc., etc. On top of this, there is knowledge, and knowledge is information in context, meaning in the world of intelligence, it's called connecting the dots. Take several type of information pieces, connect them together, and you get some kind of knowledge or insight. And usually, when we speak about information, we are answering the question what, who, where, and when. And when we are speaking about wisdom, we are answering the question how and why. Now, this is roughly speaking. This is not accurately, because you can have different layers of data, and you can have something which is very low-level information that is built on this more high-level information, and then comes the wisdom, etc., etc. So the knowledge. Wisdom is about at the top, because at the beginning there was only DIK. Wisdom was added to describe actions. Again, the definitions are quite shaky. You can find them on the internet, it's okay. I'm not going to try to make it up. Questions? So we are going to speak a lot about data in this course. Next, let's speak about the infrastructure. And it's a chance, by chance, that infrastructure is the bottom. Let's speak about storage and about cloud. So when we speak about this type of topics, again, many terms, file system, database, etc., etc., etc. I'm going to try to give you some idea on them in the next slide. Let's start with data storage. Well, you need to put your data somewhere. This is called data storage. So you can store information on notebook, but if you would like to use it on a computer, of course, you will need other terms, like this is a hard drive. If you open your computer, and I don't recommend it, then you see something like this. This is the hard drive, okay? And there is a floppy disk, and a CD-ROM, etc., disk on keys, flash drives, okay? So this is the basic, this is the data storage. On top of it, we can speak about data itself, and we define data, the volume, by the word which is a byte. A byte is 8 bits. Bit is either 1 or 0. Take 8 bits, consider them together, and you got a byte. And when we speak about volume, we speak about magnitude of bytes. So it's either thousands of them, and there it's kbytes, megabytes, gigabytes, etc., etc., etc. Okay? Questions? My first computer, when I was a child, has 64K. That's it. Nowadays, one image is 1.5 mega. One image. Okay? Speaking about advance in computing power. Next, if you speak about those hexa, zeta, and iota, you don't going to have them at home, at least not for now. Nowadays, by the way, if you will buy a new building at the store, you list it there, at least. So we are going to see petas soon, but those I don't think we are going to see soon, but companies like Google, of course, deal with those volumes. And then you will see rooms packed with many machines like this, disk machines, and you'll get those type of volumes of data. And this is the meaning of the word cloud. So you have data centers with a lot of data that you connect to them from remote, and this is basically the whole idea in what is called cloud computing. Inside the machine itself, there is the logical level on top of the physical one. And now we define something, let's say a file system. We are taking the metaphor from the real world. So there is a cabinet, and there is a folder. In the folder, we are putting files like a PDF file or Word file, etc. And there is another thing which is called a database, okay? And this is the database. It is represented usually by a cylinder, and usually on the cloud you find many databases. And this is something which is called a distributed database that will find the database distributed and divided between different sites, even between continents. Now, the main task in data processing is retrieval, meaning just to gather information or data and store it, it's quite easy. The issue is to find it. Okay, all of you, if you have a cupboard in home, you know that to throw things in, it's very easy. To remember what you have inside, well, this is the issue. So the whole idea is to try to find ways to retrieve the information in a fast way. And we are speaking not only about tabular information or data, but also about images and text, and this is not an easy task. Just to give you a very low-level illustration of why do we need these databases, I'll give you this example. And this is a physical library, okay? Let's say that you got now task or punishment to summarize all books in this library. If this is the case, do you care how those books are ordered? Well, the answer is, of course, no. If you need to go over all of them one by one, why do you care? Okay? But let's say that you are now know happily that you only need to find the 2 books that Mr. Jones was published. Only 2 books. Now you really care about how the library is ordered, because if you need to find only 2 books in this library, you want to find it. You don't want to go over book by book and look for the books of Mr. Jones. So happily you found out that it is ordered by the author name. So all you have to go to do is to go to the shelf of Mr. Jones, J, and you'll find there the books. Okay? But now let's say you don't need to find the books of Mr. Jones. You need to find books by the title. So if the library is ordered by the author name, it's of no use, right? How can you find by the title? For this, you will need something which is the catalog, okay? Which is going to be ordered by the name of the book. And this, in the size of this library, this is how the catalog is going to look, okay? This is a very small catalog. Libraries, real libraries, this is the catalog. So now there is the question, how am I going to sort and order this catalog? Okay? And even so, if I order in, let's say, usually the books are ordered by, let's say, author name, and this is going to be ordered by the title of the book. Now I need to find all books that discuss the King Paro of, well, whatever. But not necessarily said in this name in the title. So what now? For this, you will need the index. The index that each word or each topic, important topic, is going to be written. This is, of course, an index of a book, okay? For a whole library, it's going to be much larger. And basically, this is what Google does. Okay? Google holds an index of words for the whole documents on the internet. Okay? So this is a very quick illustration of why one needs databases. Questions? And in databases, there is something which is called the index. And here I describe shortly rational database. And in a rational database, you have what is called tables. And in a table, you must have something which is the key of a record in order to be able to retrieve it. And again, a very quick illustration. Let's say this is the table of all employees in my organization. And now I would like to find, let's say, employee 46. Okay, now in this short table, it's quite easy. Well, it's here. But let's say this is not an employee table, but the registry of India. Well, it's going to be harder to just go and read all the registry of India in order to find employee 46, right? So for this, I have an index. And the index in this case says that go from the top. I'm looking for 46. 46 is bigger than 33 and is smaller than 47. So I'm going to go here. If it go bigger, I go there. If it was smaller, I go here. Now, here I see there is 41, 46, and I get it. Okay? Again, a very quick illustration of what the term index means. Questions? I'm not going to cover databases more in this course. This was just, as I said, for your enrichment of what does it mean that the database is. Another term that was coined about 30 years ago is data warehouse. And also there is the term data mart. It's also here. Those are basically buzzwords, commercial buzzwords, with an idea behind them. It means that there are in an organization many systems, computerized systems. Each of them, that's an operational system, and we have files. Each of them has its own data. You are going to take all those data sources, put them together. This is called staging, and all these type of manipulation is called data processing. I'm not going to speak about it at all. And then you put everything in one big database, which is going to be called the warehouse. Now, let's say you are only dealing with sales. So you don't wish to get all type of data information. So we will take some portion of everything and we put it for you. So this is the data mart of sales. This is the data mart of purchasing, etc., etc. And what you can do with it, you can do some kind of data analysis, you can produce reports, and you can do something which is called data mining. Okay? This is the concept. I'm not going to speak about any of this. I'm going to concentrate in this course only on the analysis. Okay? Because this is the most important, the more important and interesting, in my eyes, task. Questions?
Explain again what's a data mart.
So,
Data mart.
data mart is a part of the data warehouse. Data warehouse, everything data mart is just for vertical. Let's say it says. It's a buzzword, nothing more than this. Okay? Now, let's focus on big data itself, because you will see this a term in many papers. And what is big data, or what does it mean to have big data? Well, again, the definition here are not strict. I'm familiar with people that works in the interior office of Israel, and they will say that they have big data. I'm not sure if their colleagues in India will agree, because the whole Israel is one village in India. So what makes big data big data? Again, it's a buzzword. And you will see in many papers, people describe the viz of big data. I don't know why. If you'll see this, the people who wrote this paper have no idea of what they are talking about. Now, I'm going to describe this to you. Hopefully you believe that I know what I'm talking about because you will see it, okay? But let's go. Let's first think that characterize what is a big data. It's the volume, megabytes, terabytes, etc., etc. Okay, how many data do you have? How much to store actually? Next, velocity. Velocity stands for how fast. Okay, how fast is the ingestion, meaning getting information in. Processing, how fast do you need in order to, how much time do you need to process it? How fast do you get updates for this data, etc., etc.? Next, variety. What are the different forms of data? Only tabular? Do we have text? What is the semantics, meaning the meaning of this data information item that you collect? What are the sources? From where do you get it? Veracity. Veracity is a very nice word in English that actually stands for reliability and accuracy. Why veracity? Because it's in V, okay? And function enough, there are not many words in V in the English dictionary, but there are more. Veracity is how accurate is your data. Now, this is a big issue because, again, if we're speaking about health data, unfortunately, medical records usually are not accurate. Doctors are doing many, many mistakes. Those who are trying to analyze the medical records are aware of this, and this is the real issue. How are those data are reliable? Can you trust them, even if they are accurate? And there are cases that they are not, and I'm going to mention them. Because value, what is the relevant piece of data for you? Is it usable? And this is something that happens, and I made this before many times, that you are collecting a lot of data, and you would like to do some kind of a task, but the data that you collected is not relevant for this. Okay? Variability, meaning how many updates, how frequent your information is going to change. Is it going to change? Some data is not. Let's say that phone companies collect information about whenever you are doing a phone conversation. So they took a log or a record, and that's it. It's not going to be changed because this happened in the past. That's it. This is not the situation for banking information because there are deposits, you buy something, right? So it's always applicable. And volatility. Volatility means for how long this type of information is relevant and what is the latency. How much time occurs between the time that this data information was created until you got it. And this, for instance, think about the autonomous car, okay? The autonomous car is moving. Now, there is an old lady in front of me. If I get this information after I'm going to run over her, well, it's not relevant anymore. Okay? And this brings me to another section of databases and real-time streaming analytics, because this means what I mentioned before is about big data, meaning storing, analyzing. But there are cases that you cannot afford this. You cannot afford to store and put everything in place before you analyze it. You must analyze it while it is on the way. And here, of course, the velocity and volume are very, very critical. And this is, for instance, stock market. You cannot wait a week before you analyze what is going on in the market now. You have to take action now, okay? I mentioned autonomous car, and also when we are going to speak about security, after the terror act was happening, well, who cares, okay? So there are many tasks that you cannot wait. You must analyze the information on the fly. And as you can see, there are many, many aspects of actual design of big data. So those V-words, the concept of very nice collection of words starting with V, that really say anything. Yes.
Or with big for your
Yes.
vulnerability.
Yes, but we are speaking here not about cyber, but about big data. We can also add how vulnerable is the big data. Okay. So now let's go to the top of the cloud and let's speak about analysis. Again, there are many, many terms here, but first let's speak about the idea of data analysis. There are many, many methods or techniques to analyze data or information, and I'm going to introduce them throughout this course. This is the whole idea. And the way to analyze your data depends a lot on what is your goal or start. Now, it sounds trivial, right? Believe it or not, it's not. Because I mentioned before that many times you collect data and you want to achieve some task, but the data you collected is not relevant. And I found out that in several cases, the people ask me, help us to do something relevant or to do something with our data. Okay, so I'm asking, what is your goal? Something nice. Okay, now it's amazing, but if you would like to do some kind of analysis for the data or information, what is your goal? Then what is the type of data? It's not the same to try to analyze tabular data or text data or image data, and I'm going to demonstrate it throughout the course. You need to approach it in different ways. And then you will have to ask yourself, what is the quality and reliability of my data? As I said, if it's a medical records, I must do something in order to deal with this issue because those are real issues in those fields. What are the data volumes? If I have one Excel file, it's not the same like Google have huge volumes of data. I cannot use the same method. And of course, what is the prior knowledge? If I know already several things, why should I try to analyze and get insight on them again? And it may sound funny, but it's not. I'm going to demonstrate this, that many times this might happen. Questions till now? So I'm going to cover now those terms: statistic, algorithm, rule-based, data mining, knowledge discovery, business intelligence, and machine learning. Let's start with statistics. When I was a young soldier in the army, I basically did AI, but nobody told me, because it was a long time ago, and the term AI was not familiar as today. So people told me that I'm doing statistics. Nowadays, probably it was called AI, okay? And what is statistics? Statistics is a branch of mathematics, and it deals with the collection, organization, analysis, interpretation, and presentation of data. If you recall, when we spoke about what is AI, is collecting, analysis, and get insight, which is interpretation, basically. So it's most of the terms are already here. There are two branches inside statistics. One of them is called descriptive statistic. This is about mean, standard deviation, etc., etc. Probably you are all aware of it. And there is something else which is called inferential statistics, which means draw conclusion. You remember insights from data. And this is based on the sister of statistics, the probability theory. Okay? So when we involve both statistics and probability theory, we're actually dealing with inferential statistics, and many AI algorithms are based or were born from here. It's the same thing, but with new branding. That's it.
It's called data science.
What?
Data science.
Data science is now the branch or the topic in university is called data science.
Okay. Literally something like,
It's a new buzzword.
yeah.
And those people who learn how to analyze data and deal with AI nowadays learn data science. Okay? Basically, there is only one science in the world, which is physics. All the rest are knowledge. Algorithm. This is a new word, another word which is quite ancient, by the way, and it comes from Arabic, if you don't know. And algorithm is basically a finite sequence of well-defined instruction to solve some specific problem or task. Okay? Usually they are drawn with something which is like this, flow charts, and this is a very small and stupid algorithm of dealing with lamps. If your lamp doesn't work, then first check this diamond question, check if it's plugged in. If it's not, then plug it in. If it is, maybe the bulb itself is burned out. If yes, just replace it. If no, repair lamp. This is a very stupid algorithm to demonstrate this. Also, baking a cake is an algorithm because you have ingredients and then you have a finite steps, finite instruction that you do from ingredients to bake, to cake. Okay, it's the same thing. Knowledge discovery and data mining, two terms that were born in the 90s, I believe. Knowledge discovery is about extracting useful knowledge from data. So first, you see the knowledge word appears here and there. Actually, I copied this from somewhere. It's not a good definition, right? So find something interesting. This is the idea. Data mining is about discovering patterns. And we'll see in this course algorithms that basically are designed for patterns. And those two basically speak about those three steps. Gather information or data, analyze it, and get insight. The difference between this and what I showed you before is that there are no actions. So knowledge discovery, data mining are just stop at the insight step. If you would like to translate it also to action, then it's not there. You need another thing. Questions? I'm not going to deal with these terms later in the course. I just put them there because they are common, so you need to know them. This is a very interesting chart, which is around for about 40 or 50 years, 40, I think. It's called the CRISP, Cross-Industry Standard Process for Data Mining. And it describes the steps that you need to take in order to conduct a data mining or whatever, data analysis process. So first, you need business understanding. This means, what do you want to do? What is your goal? Okay, start with this. Then data understanding. Analyze your data, and I'm going to dedicate one class for this. What can you actually get from the data? Is it good enough? Note that there is an error back. What I said, sometimes you can't define the goal. You go to the data and you see that you cannot achieve your goal from this data, so back to square one. Let's say that I know my business, I know my data, so now I have to do some boring stuff of the preparation that I'm not going to cover. Then I'm going to start to do analytics, which is standing here, the word modeling, which I'm going to speak about it next week. After I did the modeling, I need to evaluate. And now there are failures, okay? Sometimes I evaluate it and I see that it doesn't work. So back to square one. If everything is fine, then I can deploy. And there is this error, because this work never stops. Because different situation, new data, market is changing, etc. You need to build your model again and again and again. And this is the reality. It's not just a very nice picture that I showed you in the class. Questions?
DM.
Data mining.
Why didn't you put an L between the deployment and the business understanding? In many cases, the deployment lead to a new business understanding, and then it's lead to a
This
new.
is the circle.
Okay.
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 This stands for go back. This stands for cycles.
Yeah, no, I'm saying between the deployment to the business understanding. So
And
even when I
this is
deploy, I got a new result, I got a new, but then it's lead to a.
This is the cycle.
understand.
This is the next cycle. This is failure. It's not the same.
Yeah, of course.
So this is why they put it like I didn't, of course, invented this. This is why the people who created this put it like this. So this is okay. This is, as I said, you never stop the work because you need to go again. Maybe, as you said, I find new information. I would like to launch a new project, or the environment is changing. Okay, this is actual failure. Here, and also here. Because many times you cannot model it because the data you created is not good enough. I didn't mention this. Okay, questions? So let's take another 10 minutes. We're going to start again at 5 after 5.
לא, אבל שמעתי שרים.
נכשלו וממנים ותתתים.
אבל זה כל הצבא נחשב. כל מי שתגיע בדרגים האלה נחשב. אין אחד שלא נחשב. אני לא מסכים עם זה. אני חושב שהיא קצת... יש כאלה יותר, יש כאלה שפחות, אבל בגדול כולה כשלה. ולא התנהלה כמו שצריך.
שוב, עובדתית כן.
עובדתית, תעזוב אותך, עכשיו סיכוי סביר שאתה מכיר מישהו שיש פה איזושהי מעורבות או משהו שם עליו. מי יחליף את הרמטכ"ל? מי יחליף את... ראש אמ"ן?
אנשים
כמו שהביאו לך את זמיר, כמו שהביאו לך את זמיר, היה זמיר. הוא קורא טוב לביבי. ירצו מישהו מבחוץ, ועשו כל מבחוץ.
זה פה נסגרו עכשיו לכל מחלבים על המלחמה הבסיסית. מאיפה במדינה זה זו אלא אם כן יקום גוף.
Okay, when we speak about data analysis, basically there are two branches of it. One of them is called rule-based and the other one is called machine learning. When we speak about rule-based, usually we are going to discuss search algorithms or what is called business intelligence, BI, doing queries of databases. And we are going to discuss rules and expert system. All of these, I'm going to speak about them later. Of course, when we speak about machine learning, we are going to speak about pattern recognition. If you recall, data mining also talks about the patterns. And we are going to speak about different terms like supervised learning, unsupervised learning, and reinforcement learning. Rule-based AI, I mentioned it at the beginning, the history part. I mentioned the concept of knowledge base, taking information from experts. And the idea is that once you took the information or the knowledge of this expert, you encode it with facts and with rules. And rules are what is called if-then statements or queries, which when I'm going to speak specifically on this, I'm going to get into the details and to try to capture the knowledge as I see. Now, this is rigid intelligence, meaning you have what you got. You got what you got, nothing more. You cannot go not right and not left from the rules that you have. Like any other rule system, like the text system, the law system, all of those are rule systems. And they are very, very strict and rigid. Machine learning algorithms are different. We speak about the notion of learning algorithm, meaning that the algorithm knows how to change, how to adapt, how to be flexible. And this is the concept of adaptive intelligence. So the machine not only acts on predefined knowledge and rules, but knows how to act and handle new situations via analysis, self-training, and experience. And each of these imply different type of learning, which I'm going to cover in this course.
Why didn't you also mention that machine learning means that the machine will create the rules to itself? So if in the rule base you give the data and you give the rules, and then it's providing an answer based on the data and the rules together. In the machine learning, you give the data and you just say what is the wrong data and what is the good data, and then the machine should create the rules and learn the data, create the rules, and acting accordingly.
Okay, we are talking about two concepts here. One of them is what the machine does. The second one is how the machine represents its knowledge. It's okay to represent the knowledge even in machine learning in rules. Okay, but in rule-based systems, you give, as a person, I give all the information in advance to the machine, and that's it. In machine learning, this is not the case. I give it part of the information, and it knows to add on it. Okay?
The machine knows how to create the rules to itself.
To create more knowledge. It can be represented in rules or in other means, for instance, neural networks, which we are going to discuss, okay, which is totally different from rule systems, okay? The idea that in learning, you don't only get one-time snapshot of information and knowledge, but you can change it, discard it, add on it, which is not the case in rule-based system. Yes, human can do it, but not a machine by itself. This is the difference. Let's think of it that a rule system is like getting fish. In this case, this is a bass fish. If you like a bass fish, bon appetit. If not, this is what you got. You cannot do anything beyond it. Machine learning is getting fishing rod. So if you don't like bass fish, then catch another fish. Or you can learn what to do with your rod. Maybe you can fend off flies. You can do other things with the rod. So you have tool, and with the tool, you can acquire whatever you wish. Rule-based that I gave you fish, and that's it. Okay? Strictly speaking, this is the difference between the two approaches. However, you keep in mind that still even in machine learning, whatever algorithm of machine learning, the machine still depends heavily or rely heavily on prior human knowledge. Because, as I said, I give to the machine the fishing rod. Now, in this environment, basically, in order to catch fish, you need a net. You don't have a net. You can do whatever you can with a rod. So you are limited with the definition or with the infrastructure that human built to the algorithm, into the algorithm, and we'll see it in more concrete examples later in the course. And yes, you have a lot of flexibility with it, but you don't have this. Okay? If I'm going to compare now, and of course this slide will appear later in the course, what are the basic differences between those two approaches? Then rule-based is empirically, and machine learning is about generating knowledge automatically. In rule-based, you don't need to train the machine because you just gave it once the answers. In machine learning, in several types, you need training, and we'll see it. In rule-based, there is a lot of manual effort at the beginning when you create the system to generate and maintain the rule set. This is when creating, this is to maintain it. All this is manual. In machine learning, not everything is automatically going, you still have to work. There is a lot of effort to collect samples and to tune models, and of course, I'm going to discuss this and explain what does this mean. Rule-based, as I said, is rigid. It cannot work beyond rules. Again, think of text system. Text system is very strict. Machine learning is flexible. It can adapt to new cases, and we'll see different algorithms that knows how to adapt to new cases. And all of this, after we are going to get deeper into each of these methods, of course, we are going to get back and discuss this. Questions? The approaches that I'm going to cover in this course, by the way, it seems to be that they are going to have 12 meetings, not 13. So I have to pack the lectures to 12 weeks, not this. I'm not going to start this today, but keep in mind that this is what I'm going to do. I'm going to cover supervised learning, and I'm going to start with this. Supervised learning is one of the most important methods of learning, and that here I'm going to cover, starting from next week, the notion of classification or regression and what is called predictive analytics. Later, I'm going to discuss, and I'm going to dedicate, I think, 3 or 4 classes supervised learning. Then I'm going to dedicate 1 class to the concept of unsupervised learning, meaning that you don't need to supervise the machine. I'm going to explain it in the next slide, but of course in depth in the course. And I'm going to discuss 3 different techniques, which are unsupervised, clustering, anomaly detection, and association rules. And I'm going to discuss also other things which are falls under machine learning, which is reinforcement learning and evaluation algorithm, which are kind of in between those 2 approaches, but yet it's premature to give you the full understanding of this. This is just a problem. But leave you without anything, it's not a good idea. So I give you just a hint of what is the difference between supervised and unsupervised. Let's say on supervised first, I have pictures of fruit in this case, and I would like to teach a machine to make a difference between, or to identify apples and not apples. Note that I put on each of these images, I put a label. Here I put apple, and here not apple. Note that I don't put the name of the fruit, it doesn't necessary, just happen, not happen. And then I'm going to use one of the techniques of supervised learning, and I'm going to get what is called a model. This is the learning step. The deployment steps come afterwards. And in this case, I expect to give to the model, to the machine, just a picture without the label, and to get back, if everything is working, that, well, this is an apple. This is the basic idea of what does it mean to have supervised learning. Okay, so I guide the machine with examples with known answers, and I'm going to challenge it later on with questions of what is this? Okay? In contrary, unsupervised learning, I'm just going to give the images to the machine without any guidance, no labels, and then I'm going to use an algorithm of unsupervised machine. And in this case, I'm going to expect something like divide those items into groups. This is called clustering. And in this case, you can see that several fruit looks together or looks alike because all of them are circular, let's say, and the banana is not. Of course, if I thought, in this case, the machine basically divided them by the shape. But I could think of other ways to divide them, right? I can do it by color. And then maybe these are together, and this is green, and this is yellow. Okay?
In unsupervised learning, there are still rules for clustering, right?
No, the algorithm is called clustering, and there are no rules here. There is an algorithm of clustering.
You just said that or I can choose to divide it by the color. So
I need to define beforehand for the clustering algorithm some definitions. Again, if you recall the fishing rod and fishing net. So I'm going to use a fishing rod. Okay, whenever I'm going to speak in depth on the algorithm itself, of course, I'm going to explain this.
When would you use like supervised versus unsupervised?
So those are two types of algorithms. Okay, and I'm going to discuss them. Okay, and then, as I said, I'm going to dedicate, I think, 3 lessons to this and 1 lesson to this. And then I'm going to, of course, give examples of application. Why do I need it? Or what can I get from it? Yes.
Okay.
Yeah. Yeah. And we'll see that many times this is what one should do. Okay, more questions? So that for now, and again, I didn't give you a lot of knowledge about it. This slide will appear again later in the course. The main difference between supervised and unsupervised is that supervised meaning learning by training. There is a teacher, like this robot that's learning for school. In unsupervised, it's by doing. This is not a good example, but I didn't have a different picture. In supervised, I need to do something which is called labeling. If you recall the labels apple, not apple, this is a step that I don't need in unsupervised. The goal in supervised usually is to get labeling or prediction for things that I don't know, that I didn't teach the machine. And in unsupervised, the goal is to discover patterns or groups or clusters, etc. Meaning this is more task-driven because I have a specific goal, I have a specific task, and in unsupervised, it is more data-driven because this is an explorative analysis. And many times this is going to be done before that. And again, I'm going to give you later in the course examples. Here, because this is task-driven and I know what should I expect, I can measure it. Here, there is no real right and wrong, because if you recall the fruits, I told you that it was divided by shapes, but it was could also be divided by colors. So what is right, what is wrong? There's no actual definition there.
Don't you give
No, no. Again, we'll talk about it. Yes.
Isn't it that those algorithms are working on a set of data that someone, some expert, human expert, would say that this piece of information is correct and this piece of information is incorrect,
This is supervised.
but the unsupervised do not get like
No. Let's go back for a very small example here. I just gave images and ask it, please divide it. Okay, and I can get different type of divisions and there is no actual right and wrong. Okay,
okay.
this is unsupervised. This is the whole idea of the word unsupervised. I'm not going to supervise you, just do what you ever want.
There is no teacher, there is no supervised, but still I know where I want to go.
No, I just want you to divide these groups, and I'm going to look at it and say, okay, I got you. Those are circular, and this is like perfect. This is exploring. Okay, again, it's premature. We're going to speak about it later in the course. The questions are good, but bear with me. I am going to dedicate a class to image analysis. In this case, for instance, you see an example of object recognition, for instance, pedestrian. As you can imagine, this is important for autonomous cars. You don't want the autonomous car to run over people. So I'm going to explain what does it mean to represent images in a computer, what should I expect when I do image analysis, and give you the basic idea and the basic concept of this field. Of course, I could dedicate the whole course only for this, but as I told you, I'm going to speak about broad topics. And there is going to be one class dedicated to text analytics. If you see here, consider it as text. Those are words. This is just an algorithm that I'm going to discuss when I'm going to speak about text. As I said at the beginning, if you have text or images or tabular data, the different algorithm and different approaches should be taken because this is not the same thing. So I'm going to explain the idea of what does it mean to analyze text, what is text, etc. And I'm going to dedicate one class to link analysis. Link analysis is about networks. Here you just see one algorithm which is called centrality. 3 types of centrality. Of course, I'm going to explain this when we are going to discuss this. And this is very interesting because nowadays a social networks analysis is based on this and many, many other tasks. And I'm going to describe this. This is a different field of AI that deals with this type of algorithms. And I'm going to dedicate a few topics to discuss generative networks, generative AI. This is learning how to generate. It's quite new to the field of AI. I'm going to speak about what is called GAN. Okay, I'm going to explain this later in the course. And all of you heard about ChatGPT. ChatGPT is based on what is called GPT architecture, and GPT stands for Generative Pre-trained Transformer, and this is a transformer. Okay, now I'm not going to teach what is a transformer, because I will need several classes just to explain this diagram, and I'm not going to do this. I am going to explain to you the concept of how transformer is working, its application, and its limitation. And I'm going to explain actually these types more because it's easier to understand this than that, technically speaking. Okay? And in this class, of course, I'm going to mention it both when we are going to speak about images and we are going to speak about text. And in the end of the course, when I'm going to speak about the dangers in AI, of course, generative AI is a huge danger to our world. More questions?
I think I have 5 different meaning of what GPT means. Every time someone says GPT it means, but it's different. Like I never saw pre-trained before.
Well, GPT stands for Generative Pre-trained Transformer. This is the fact. I'm not.
Amazing. I think like 5, even in the cyber day that we had, someone said GPT means and it was different.
No. GPT is Generative Pre-trained Transformer. Okay? I'm definite about this. Okay, and transformer is an algorithm that is based on neural networks that I'm going to explain in length. Pre-trained meaning supervised, okay, that you need to train it in beforehand, and generative because it can generate. That's it. Now, ChatGPT is a GPT that was tuned for chat applications. But GPT stands by itself and it can do a lot of things, which I'm going to discuss. As you saw, I told you about ELIZA from the 1960s. So ChatGPT is not a new concept. Of course, of the world, because of the lot of buzz and noise, everybody heard about it last year. I'm familiar with it for about 40 years. Okay, so it's not a new concept. And you will see that in AI world, there are a lot of trends, ups and downs, ups and downs. Algorithms are the queen of the class queen, and then a few years later, nobody wants to do this algorithm. I'll show you this. More questions?
Do you think after the moon gonna be also winter?
For ChatGPT?
After AI winter.
I'm going to speak about what is called the Gartner Hype Cycle. If you're not familiar with it, you can look it up. And you will see that in Gartner Hype Cycle, it goes like this, down, and then up again. And we're going to see the same thing for ChatGPT for sure. More questions? Okay, see you next week.